Welcome to Mexico for the total eclipse that's coming up in less than a week now. Traditionally, we do this pre-eclipse briefing to give you an idea of what you're going to see, hopefully, and also tell you why it happens and lots of other interesting stuff. But we all know why we're here. We're here because of an amazing celestial coincidence. And that's the coincidence that the sun is 400 times further away from the Earth than the moon is, but it's also about 400 times larger. So if we're lucky and if we're in the right place, we can see the moon cross across the sun, and if the moon is large enough, the moon will block out the bright disk of the sun, a thing called the solar photosphere. And there are two kinds of central eclipses where that happens. The one at the top there is called an annular eclipse. It's not called an annular eclipse because it occurs every year. It's called an annular eclipse because you see a ring of sunlight around the moon. So an annular eclipse happens when we're on that center line, that important center line, but the moon is too far away or the sun's too close, so the moon's not big enough to cross over the sun. Annular eclipses are really interesting to see, and many of you may have seen one last October which crossed the US. They're kind of interesting to see, but in reality they're not that much more exciting than a partial eclipse. What's really exciting, and the reason that we're all here, is that central eclipse where the moon is big enough to block out the entire solar photosphere. So the bright disk of the sun that normally overwhelms everything else is blocked out, and we can see all of the other features that I'll talk about in a minute and which Nick will talk about through totality. So the graphic here is just a demonstration of why we don't get eclipses every month, because essentially to get an eclipse the moon needs to be new. It needs to be between us and the sun. And of course the moon goes around the Earth every month. So you might think, well, why don't we get an eclipse every month? The reason that we don't get an eclipse every month is that the moon's orbit is tilted with respect to the Earth's orbit. So in order to get an eclipse, the moon doesn't only need to be new, but it needs to be at what's called a node. So a node is where the moon crosses the plane of the Earth's orbit. And that happens quite rarely. I think on average a central eclipse occurs about once every 18 months or so. But on average, if you stood in one place on the Earth, I think you'd see a total eclipse maybe one in 400 years or so. So we're very lucky these days that we can travel around the planet and we can see total eclipses from lots of different locations. And all of my vacations really for the rest of my life are planned out by charts like this. So this shows the track of that very narrow area where you can see either a total eclipse, which are the eclipses marked in blue here, and this is the one that we're going to get next week, or an annular eclipse, which are the ones marked in red. So some of you will have been in Australia last April, about a year ago, when we had a very, very short eclipse up here at Exmouth, right on the coast of Western Australia. Many of you will have seen other eclipses here. One really interesting one that's coming up is this one in 2026, August the 12th, which is going to cross Spain down here and some holiday islands. So some people who are taking package holidays to Mallorca are going to have an interesting afternoon when the sun goes out. But there are other places to observe it as well, and Greenland and Iceland are really interesting places to go. Of course, if anyone's interested in going to those future eclipses, talk to Brian and Julie in the front, because I'm sure they can sort you out. But lots of eclipses coming up, and we're just very lucky to be able to travel to them. One of the interesting things about the way that eclipses work is that they work in series called Saros series. And that's because the conditions that we need for an eclipse to occur is that the moon must be at new, so it must be directly between the sun and the Earth. It must be at a node in its orbit, and it also must be the same relative sizes, the sun to the moon. And there are three different kinds of month. There's what's called the synodic month, which is the one that we kind of know. That's the duration between new moon and new moon. There's the draconic month, which is the amount of time it takes the moon to go between the nodes. And there's the anomalistic month, which is the amount of time it takes the moon to go to what's called perigee, so the closest point to the Earth. If you do the math on that, you end up finding that if you take 223 synodic months, 242 draconic months, and 239 anomalistic months, it works out to be 18 years, 10, 11, or 12 days, and 8 hours. And that's what's called the Saros series. And these plots show the eclipses. So the one in the middle is the one that we're just about to see. The one over here was March the 29th, 2006, which we saw from the desert in Libya. Who saw that eclipse? Quite a few people. What you can see is because of this factor of 8 hours, the Earth rotates by 120 degrees between each of these Saros eclipses, but they look otherwise pretty much identical. And the next one in this series is April the 20th, 2042. So only 18 years to wait for that one. So, okay, this eclipse. The track for this eclipse, it starts out here over the Pacific Ocean at sunrise, runs rapidly across the Pacific, and its first landfall is on the Mexican coast, not far from Mazatlan. Maximum length of the eclipse is not far from where we will be at Torreon. It then runs across the US-Mexico border into Texas, and then up through the US, and then finally into Canada and out past Newfoundland. Now, the weather prospects along this track are interesting because we can predict very, very accurately the track of an eclipse. The one thing that we can't do particularly well is predict very accurately what the weather is going to be like. But we can look at the climate along the track. And that's what you have to do when you're planning an eclipse months or years ahead. You're not using weather forecasts, you're using climate information. And if we look at the track, we're gonna be down here. So why are we choosing here rather than anywhere up along the rest of the track? Well, one of the reasons is because the eclipse is very slightly longer down here. But the other reason is basically, I'll skip that one. The other reason is basically that the predictions for cloud cover are much lower in the region around Torreon than they are as you move into Texas, and then certainly as you move up through the northeast of the US and then into Canada. So given that when you're planning an eclipse, you have to look at climate, you can't look at weather forecasts, you have to really go with that. And so if you want to have the best probability of seeing the eclipse, then this is the area to be from a climate point of view. This is a really good plot by Jay Anderson that shows that, I think, very, very clearly. So this shows the predicted percentage of cloud based on a kind of average over many years at places along the track. Torreon is here, right down at the very lowest possible amount of cloud along the track. As you move into Texas, you get a bit higher. So Dallas is a little bit higher, and then it kind of goes up and down through the rest of its track. So from the point of view of the best possibility of seeing the eclipse based on climate, then where we're going is the place to go. Now, of course, we're now, and I'm still very confident, we're now at the point where we can actually look at weather forecasts, not just climate, we can look at weather forecasts. And that's got people quite worried. And the reason they've got worried is they're looking at things like this, which are what are called numerical models. So these numerical models run by national weather services attempt to predict the weather maybe sort of 10, 15, 30 days ahead by using very complex numerical simulations of the atmosphere. And they're pretty good. They're actually pretty good now. And they show things that look quite scary. So for instance, this is the cloud cover prediction for Torreon, Monday, April the 8th here. 100% high clouds, quite a lot of medium level clouds. That sounds on the face of it a bit worrying. We also have plots like this. So this is from a site called Pivotal Weather, which is worth keeping an eye on. And this is essentially turning those numerical models into a graphic that looks like a satellite image. So from the satellite, you can actually see cloud, you can see clear areas, This is an attempt to turn those numerical models into something that you can interpret as a kind of as a prediction for where clouds will be. It uses a rather weird color scheme because white areas are lower cloud densities and blue areas are higher cloud densities. The numbers in here give you a sort of percentage of how much of the probability there is, or the percentage of how much probability the sky will be covered by clouds. This is the latest one. Well, I downloaded this at lunchtime. This is from Pivotal Weather. This is the latest prediction for cloud along the track. And you can see Torreon's kind of down here in one of those blue areas where there's predicted to be quite a bit of cloud. Now, I would say that we have a number of things in our favour. The first is that at this eclipse, the sun is very high in the sky. So if we have layers of high cloud, which are moderately transparent, we will still see a lot of the eclipse through that high cloud. We may not see all of the corona detail that you would see in a really clear sky, but we'll probably still see a lot of the eclipse. I've been to eclipses in the past where predictions have been worse than this, and essentially it all comes down to luck as to whether you happen to have gaps in the cloud in the right place or not. So we are where we are. With a large group of people, we don't have the mobility that you would have if you were traveling independently. If you had a car, you could probably look at the satellite picture that morning and you could probably try and drive to somewhere where there's clear skies. We've had to arrange an observing site that will accommodate 700 people, something like that, with all of the facilities necessary to keep those 700 people happy. And so we can't just up sticks and move. So basically, the weather will be what it is. We will get you to that observing site. I still think there's a high probability that we'll see the eclipse. I've been in situations before where the weather has looked very iffy, and we've actually managed to see the eclipse either with high cirrus or in skies where we have gaps between the clouds. But unfortunately, with a natural phenomenon like an eclipse, it's not something we can control. We know we can predict exactly where the eclipse will occur, and we can do everything necessary to get you there, but we cannot control the weather yet, thank goodness, probably. And so we are going to have to take what we get. But I'll be keeping an eye on these weather predictions over the next few days. If you're interested, you can as well, but don't get yourself into a kind of thing that, oh God, we're not going to see it. There's still, I think, a pretty good chance that we're going to see this eclipse. It's just annoying that these clouds are here when all the climate predictions said that we were going to the clearest spot along the track. Of course, the thing that will tell us nearer the day is the weather satellite animations, and this is a really good one to go to. I'll put up some of the links for these later on, so you can see where the cloud is. And at the moment, you can see, it's really nice and clear there. Another thing too, we've had some contacts from the director of the planetarium in Torreon, who says that even with, when it's predicting 100% cloud cover, he sent some pictures with the sun shining strongly through that cloud. So he's really confident, and he lives there, he's really confident that even if the weather forecasts look pretty poor, that we will actually see a good eclipse. So we need to do that ritual sacrifice, Nick, just to make. Okay, so where are we actually going to be observing from? The site that we've selected is, I think it's about 40 kilometres away from Torreon, something like that, 40 or 50. It's a little bit north of Torreon. It's at a university called the University of the Arid Zone, which gives you some kind of idea of what kind of place this is. It's a university to teach people to grow crops in very, very dry environments. This is Google Earth. This lovely green-looking thing here, talk about the World Cup. This is their football field, or for the Americans in the audience, their soccer field, which is looking slightly worse for wear now. So this, I don't know when this picture was taken, but this is the area that we have allocated for us to set up on. It's a really large area. There's also shade available in a shed here. There'll be seats, there'll be other facilities, but what there won't be on the site is any opportunities to buy at least we don't think so, any opportunities to buy food or water. So you need to take that with you. A few other shots of it. Here's the football field, looking a little bit worse for wear. Should you need any exercise before the eclipse, there's a nice running track to run around whilst you're waiting for totality. And here's another one. Hopefully we won't be bothered by any tornadoes or at least whirly sand things. You'll have all been sent the eclipse briefing document, which has got the times for the eclipse. The key ones are second and third contact. So second contact is when the sun's disk is completely covered by the moon. At that point, it is completely safe to look at the sun without filters. But before that, as Nick will explain in a minute, it's not. So 12:17 and 10 seconds local time is when we expect that miraculous gap in the cloud to open up, and we'll see totality. And a nice long totality, this one. The one in Australia was 50 odd seconds. This one is 4 minutes, 28 seconds. So lots of time to have a look around during totality. I'll put this slide up at the end, but it's in your briefing pack, so you've got it, so you know what the times are. To give you an idea of the orientation, the moon will come in from the right. This is looking as if you're looking at the sun in the sky, and it will curve off and go up to the top. The reason it takes this weird curving motion is because this is with zenith up. Those of you who've got telescopes which are equatorially mounted won't see that, but if you've got an altazimuth mount or another kind of mount, you'll see this. So the key thing is the moon comes in from about the 3 o'clock position, and second contact will be at about 9 o'clock. During the eclipse, the sky will get reasonably dark. I think people generally tend to expect things to get much darker than they do. I think with this eclipse, it's a fairly long eclipse, quite a wide umbral track. The sky will get kind of late twilight dark, that kind of dark. There are a couple of planets that should be really obvious. There's the planet Venus, Planet Venus to the right of the sun here, which is very bright, and you probably will be able to see maybe 5 minutes or more before second contact occurs. And there's the planet Jupiter, which is a long way to the left of the sun, which is quite a bit fainter, but which should be easily visible during totality. There's also, you may have heard, a comet near the sun in the sky, which is quite a...
long way, about a head width?
I think it's in the briefing note, I can't remember. It's about 30 degrees, I think, from there to there. So it's quite a long way. And there's this comet too, which I'll talk about in a little while. But the main thing, of course, during totality is looking at those features that we can't see at any other time. And the main one of those is the corona. And the corona at this eclipse is likely to be really spectacular. We're approaching a thing called solar maximum. So the sun has a periodicity in its activity of about 11 years between going through minimum, then up to maximum, and then back down to minimum again. And any of you who look at the sun with appropriate filters will have recently seen that it's actually covered with sunspots at the moment. So that's really useful both for us who image the eclipse to focus on things, but it really provides a lot of interest during the partial phase of the eclipse as well. But we're approaching solar maximum, and at solar maximum, the solar corona is symmetrical and very, very active. So those of you who've seen eclipses over the last few years will have seen a more solar minimum corona, where you get rays coming out in the equatorial plane and polar brushes to the north and south. What we expect to see at this eclipse is a full-on solar maximum corona. And there's a really good simulation of that that's done by an organization called, Predictive Science, Inc. They again use numerical models, a bit similar to the ones that the weather forecasters use, to look at how the corona develops over time and to predict what it'll look like. And this is a prediction for what the corona will look like on April the 8th. The reason it's changing is because that date at the top is the last date, the date that the data was used. So essentially, as we get closer and closer to the eclipse, this model will become more and more accurate. But at the moment, it's showing a really, really active corona with lots of spikes, big symmetrical corona. as we see this from Torion, the north of the sun will be almost straight up. So we're looking at the sun's going to be high in the sky, and it will have that orientation. So what we would expect, if we get clear enough skies, is to see a very, very active, large corona. And to see that, the naked eye is really the best instrument you'll have to see that. You'll want to let your naked eye adapt as best as possible to the darkness during totality, so you see the corona out as far as possible. And that's one of the reasons why we try and dissuade people from using artificial light during totality. So flashlights, torches, flashes on your cameras, try and avoid them if you can. So that's what we hope to see on April the 8th and where we're going to see it from. Nick's now going to take you through some of the features of totality, and then I'll come back at the end, just talk a little bit about how you might make your own record of the eclipse, either videoing it or imaging it. So Nick, over to you.
Thank you, Nick. Lovely. A little relay race. Keith Foyt's quick slurp. Right. On with the show. Okay, this is really aimed for people who've not seen an eclipse before. Just a show of hands whose first eclipse this is. Oh, a goodly number. Yeah, eclipse virgins. Not sacrificial ones, yeah. Good. Well, the partial phases... Oh, sorry? Oh, right, yes, thank you. Yeah, thanks for the reminder. Yeah, the partial phases are where the excitement starts. And it's just after 11 o'clock local time where first contact occurs, where the little nibble out of the sun can be just seen. And then we start heightening up the excitement. But there is a good hour before anything dramatic happens. So you have a bit of a chance to chat. You can don't chat to people who are very intent on setting their equipment up, but because that can lead to fisticuffs. But chat to people, chat to friends, just enjoy the experience together, and slowly but surely heighten your senses. And as the eclipse progresses, the more and more of the sun gets covered. And then in the last sort of 17, 15 minutes, things start happening very much more quickly. To actually observe the partial phase, there are a variety of ways of doing it. The old traditional way is make a hole in a piece of paper and project it onto another piece of paper, but we're very conscious of ruining the planet at the moment and cutting trees down. So most of you, I'm sure, would have brought a calendar from your kitchens, and they work very well indeed, just showing little partial phases as it progresses. There are trees at Torion at the site we're going to, and maybe through foliage you'll see these little crescents, which are quite good just to catch a glimpse of things, just a bit different. But of course the things we recommend most are what we will be giving you, which are these special Mylar filter glasses, and I'll come back to those in a bit of health and safety. So the phenomena in the last phases of the partial phase are really these. Light changes, these become quite subtle and then much more dramatic. The colours can change quite nicely. Shadows become very much more sharp as the sun becomes more of a sliver. If there are any birds and any animals at the site, particularly birds, they tend to behave as if it's dusk, and they will go to roost if they're birds, not if they're llamas. Oh no, we had those before. And you will note a drop in the temperature. We don't quite know how much it'll drop, but you will notice it'll get a bit chilly, potentially. Nick has already mentioned that the planets become visible, certainly Venus, probably 5 minutes or so before totality. And then we can wait for the moon's shadow to scud across, coming from behind us if we're looking at the eclipse. Comes over at quite a lick, about 2,500 kilometers per hour, so it's moving pretty fast. And then the very, very last few seconds of totality, of the partial phase, we get Bailey's beads and possibly shadow bands. Now, Bailey's beads are really the last part of the sun's surface, the photosphere, shining through the valleys of the lunar limb. And they sometimes can be likened to a little diamond ring before totality, or sometimes a little engagement ring. As I got married in August to Pamela, she likes rings, so a couple of rings are good. And then we may be lucky enough to see shadow bands. Now, shadow bands are scintillation caused by a sliver, a tiny bit of the sun's light poking through, but being distorted by the atmosphere. And the shadow bands sometimes look a bit like dark and light bands waving across the bottom of a swimming pool. They tend to be only for a few seconds. This was a particularly good example taken by Nick in Libya in 2006. And sometimes it's good if you've got some white source surface on the floor to be able to see them. We are recommending you do not take your sheets from the hotel for this purpose. We are not liable for that. So. And then, of course, we get to totality. From totality, you must not use the Eclipse viewers. This is a time, 4.5 minutes, where you can look at the sun directly. Well, you won't be able to see it because the moon's in the way, but you'll be able to see all the phenomena. So prominences on the limb. These are filaments of gas, plasma being ejected from the sun along magnetic lines from sunspots, or sometimes just from active regions of the sun. And they can be very dramatic on some eclipses. On eclipses where the moon is relatively small but still causing totality, you can often see a whole ring of prominences. This probably won't be the case on this occasion because the moon is relatively large. So you'll see prominences, if there are some, there should be some, on the left, sort of the 10 o'clock position to begin with, and then as totality moves on, you'll start seeing them at about the 4 o'clock position as the moon moves away towards the edge of the sun again. The solar corona Nick's already dealt with very well, but it is something, the most spectacular part of a total eclipse, I think. You won't generally see quite the detail that Miloslav Druckmuller has got on these two magnificent but highly processed images. But with a pair of binoculars, use them during totality, it really does enhance the experience. Also, with a relatively long eclipse like this, 4.5 minutes, if there is time to look around you for different colours, for different effects. If there are clouds, there may not be, but if there are clouds, sometimes they can be enhanced at the time of an eclipse. This was a beautiful one that Nick and I saw in the Gobi Desert in 2008. They were very, very spectacular. And then the diamond ring occurs. As the moon moves away from the sun, suddenly you have this burst of photosphere again, and then you have to basically stop looking with your optical aid and get back to filtration. That's very important. No bit of the photosphere is ever safe. After totality, things go backwards, if you like. The partial phases slowly but surely give way to the end of the eclipse. A lot of people do like taking photographs and images of the whole caboose, so be sensitive to people who are still there. The champagne may be being popped, but try not to get the cork aimed at anybody who's still imaging. After that, you can have a drink and a chili, and I'll come to that now. Now, health and safety before the eclipse. First and foremost, the night before the eclipse, or breakfast, if you're into the Mexican food, big one, don't have chilies. We have got toilet facilities at the eclipse site, but I don't recommend you spending too long in there, and chilies may cause discomfort. Equally, tequila, many people love tequila. I wouldn't have too much of it the night before the eclipse. I don't want to see anybody looking like that on the day of the eclipse. Most importantly is eye safety. Now, on the buses, we will have these glasses, and everybody should have these. They're Mylar filters, and they work very well during the partial phases, up to totality, after totality. Do not use them during totality. The only thing that's important about these, though, again, is to not use optical equipment with them. These are not designed to be put on like this and then have binoculars. That would be a white stick job. Do not do it. It's dangerous. These are not meant for that. I suggest people hold the glasses and don't look at the sun during partial phases for any great length of time, just to see briefly how it's progressing. So put them up to your eyes, look up at the sun, and it will be that sort of level, and take them down, holding them all the time. A light puff of wind could just blow them off, and you'd be in trouble. So that's the eye safety, and I'm sure the eclipse, the experienced eclipsers will recognise that. The next bit of health and safety really is what to wear. Now, Mexico is an exotic country, loves colours, but this is not recommended. Certainly not for the men. I would recommend this as a much more sensible approach, but we're not in the States, so you don't have to have the gun. And of course, we have to think of equality these days, so yeah, equally don't have to have the gun. Hats are probably very sensible too. Sun protection on exposed parts, it goes without saying. Hats, this is probably not practical in some senses because it's probably too big. It's going to bang into your equipment if you're imaging. Something a bit smaller, baseball cap, several people with baseball caps. Nick's got a sort of floppy hat like Freddie Flintoff used to wear. A cricketer, by the way, for Americans. So a hat is almost most important. Health and safety do need to take drinks. We will not be able to get them at the site, or we don't think we'll be able to get them at the site, so bring copious amounts of water with you from the hotel. It's a very dry climate. We'll be out there under the sun for quite some time. We do also not want any lobsters. So cover up and use sun protection. Nick's already mentioned about avoiding camera flash because that does irritate people. I'm sure some will go off, but try and minimize it. And then, don't want any fisticuffs. If you do need to use a torch to look at your equipment, try and make it a red one. Bright torches can be equally irritating. Nick, recording the eclipse.
Thank you, Nick. So in this last segment, I'm just going to talk a little bit about how you can record the eclipse for yourself. I think a key thing and a key message is don't be too ambitious about trying to do that. There are certain people in this audience I know who have brought a lot of equipment and will be taking absolutely fantastic images. But for most of you, and particularly those of you who are first-time total eclipse chasers, the thing to do is to look at it visually. Yes, by all means, try and get some video or images of the eclipse using your phone or GoPros or something like that. But don't try and do anything too complicated. You've come all of this way to see this amazing visual experience. You haven't come this way to fiddle around with a camera for 4 minutes, 30 seconds during totality. So that's my kind of first warning. The second thing is that if you're new to this, or if you really want to watch the eclipse but have a record of the eclipse, an ideal kind of camera to use is something like a GoPro, or even a mobile phone just propped up shooting video. GoPros can shoot, and there are other similar cameras available, they can shoot incredible quality video. You can just set them up beforehand, leave them running through the eclipse. You don't have to do anything, you don't have to be distracted by them during the eclipse. And they'll record the eclipse really well, and even more so, they'll record sound. And you'll be amazed what you hear on that soundtrack when you play it back after the eclipse. People get very, very, very excited. If you do plan to do that, though, there's a couple of things I'd suggest. So this doesn't apply to GoPros because they're fixed focus. But if you're using something like a mobile phone to take shots, time lapses or videos, make sure it's fixed on infinity focus. I'll show you an example of what can happen if you don't do that, if you leave your camera just on autofocus, and the results generally are not very good. The other thing to do is to set the camera to underexpose a bit. If you leave the camera on its normal, everyday, automatic setting, what will happen is that it will essentially overexpose the eclipse sun. Because the eclipse sun is a very small thing in the sky, it'll turn up the exposure to expose the sky correctly, but that will overexpose the corona. So have a look, and if you look in your phone menus or if you look at your GoPro menus, there'll be a mode in GoPros. There's a kind of advanced mode that you can set where you can actually set it to underexpose by, say, something like 2 stops. 2 stops is usually a good one to use. I've said there, switch off the flash as well, as we're emphasizing. That corona is going to be really spectacular, and the last thing you want is flashlights going off and flashes going off to spoil your night vision. So I've got just an example of what you can get with a GoPro. This is a GoPro 4K video shot in Australia last April with the GoPro set to underexpose by 2 stops. We've got no sound here, but the sound on this is quite fun to listen to. But there you go, you've got the sun, total eclipse sun there. Somewhere on here is Venus, I think down there somewhere. I think it comes out a little bit later. One of the things, though, that you can see is the light around the horizon. Now, this Australian eclipse, the sun was about 55 degrees above the horizon at totality, a little bit lower, well, 10 degrees lower than it is here. But the nice thing about GoPros and the wide-angle lenses on modern iPhones and Android phones is that they've got sufficiently wide angle that they can actually get the horizon and the eclipse sun in the frame. And that makes for a really nice composition. And basically, I just set this up, forgot about it, let it run through totality. And you can see as the shadow is moving away, you can see it's getting darker around the horizon here. The shadow in this particular case is moving off in that direction. You can see there's a street light has turned on here. It records all sorts of things, which in the excitement of the eclipse, when you're looking around visually at the eclipse, you forget to look for. And so having a wide-angle video like this is a really good personal record to have. And something as well which you can sort of look at afterwards and say, oh yeah, I missed that. I didn't actually see that during totality. And it's very low maintenance. And most mobile phones these days can do very, very good jobs of taking video in quite low light. But just bear in mind that thing about setting it to underexpose and setting it to manual focus. Some people still do old school videoing, and the same thing you can do with video cameras. You can zoom in a little bit more on the eclipse in that case and get a little bit more resolution. And this is where I'm just going to show you an example of why not to leave a camera on manual focus. This was in Argentina in 2019. This is coming up to second contact. You've got the Andes in the foreground there, beautifully focused at the moment. What you'll see, what happens at second contact, is the camera goes out of focus. So do remember, if you're doing anything to do with video or wide field, to set your camera to fixed focus, set it on infinity focus, focus it on something reasonably far away before totality, and then just leave it to do that. Don't fiddle. If you notice something's gone wrong during totality, I really suggest you just leave it. Don't fiddle with it, because all you're going to do is waste all that precious time trying to figure out what's gone wrong. And 9 times out of 10, you won't figure it out because you'll be under such pressure during the eclipse. So just leave it be. Of course, modern cameras, both DSLR type cameras and mirrorless cameras, can do a really good job on totality. Usually with those cameras, you can actually set them to do what's called bracketing the exposure. So you don't need to set them to take fixed underexposed. You can set them to sequence through doing, say, 2 stops under, and then the right exposure and 2 stops over. And to give you an example of what effect that has, here are 3 photographs taken within a few seconds of each other at the Eclipse in 2017, where I was in Nebraska. 2 stops underexposed, normal exposure, 2 stops overexposed. So if you look at your camera, if you've got a mirrorless camera, you want to again set it on a tripod just to run through the Eclipse and take a time lapse or take a sequence of images, have a look to see whether you can do this bracketing exposure. It's a very easy way of making sure that you probably will get some really well exposed images through totality without having to worry about any of the technical details of exactly what exposures to use. If you're after longer focal length images, and I would really strongly suggest against this unless you really know what you're doing and you really want to have a go at this. One thing you're going to have to bear in mind at this eclipse is the sun's going to be very high in the sky during totality. It's going to be almost 70 degrees up. If you had a look at lunchtime today, the sun is really high up there. So if you are going to try and take images with a camera with telephoto lenses and you want to put it on a tripod rather than hand hold it, then just make sure that you can actually access that height above the horizon using your tripod. There's quite a lot of mounts that will basically just, you'll bang into the tripod legs, and make sure that you work that out before the eclipse. You don't want to find that out on eclipse day. Nick mentioned about the eclipse glasses that we're going to hand out. Very important to point out that they are just for naked eye use. You must not use them with optical equipment. You can use them in front of the lens of a mobile phone, for instance, to try and get some pictures of the partial phase, but you shouldn't use them, you should never use them behind the optics. So, you know, I've actually seen people bring binoculars up to their eyes whilst they've got eclipse glasses on, and that's absolutely a no-no, because you're just concentrating all the light, this is during the partial phase, all the light onto those filters, and that's extremely dangerous. Generally, if you're imaging, you'll have appropriate filters for the camera lens that you're using. I have a glass filter, but other people use Mylar filters as well. Now, I used to show this slide in the days when it was much more important. So we're very lucky these days with digital imaging in that we can actually see the image that we're getting on the viewfinder in real time. So unless you're programming your camera to try and take automatically pictures of the eclipse during totality, which some people do, you don't really need to worry too much about what kind of exposures to go for, because you can see on your viewfinder what you're getting. So at the last eclipse in Australia, some people got some really spectacular pictures just by using compact cameras zoomed up on the sun during totality. Again, remembering that key rule, which is to make sure those cameras are set to infinity focus, because otherwise they'll hunt around in focus. But people manage to get really, really good images, and you can effectively just adjust the exposure to suit what you're trying to get an image of. The prominences and the inner corona are far brighter than the outer corona. So for images of the prominences, you're talking about very short exposures. The inner corona is about the brightness of a full moon. So if you imagine the kind of exposures that you use to take a picture of the full moon, that's what you need for the inner corona. The outer corona is very, very faint, and people take very long exposures of maybe seconds sometimes for the outer corona. I think, though, these days, one of the real developments in modern cameras is that they can shoot very high resolution video, and they can shoot in what's called high dynamic range mode. So for those of you who've got a mirrorless camera who are thinking maybe of taking some stills during totality, have a think about maybe instead of taking stills, shooting some video. If you're shooting video at 4K, you can extract frames from that video very easily, and you can actually get a very nice record of the eclipse. And I'm just going to show you a video that I shot in Australia last April. This was with a Sony A7S camera in a mode that camera's got, which is called S-Log2, which is a high dynamic range mode. So the difference in brightness between the prominences here and the corona is huge. And if you shoot in a normal mode on the camera and you turn the exposure up long enough to actually get the outer corona, which is what I'm going to do in a second, you saturate the inner corona. So have a look at your camera, and if you're thinking of using your camera, so here we are, that's with it turned up in exposure, you can see the details in the corona. If you're thinking about using your camera to take zoomed up images of the eclipse, have a look and see if it's got a high dynamic range mode. If it has, then turn it on. Try and use it at night. So try it out before the eclipse. Don't do anything on eclipse day for the first time, but try it out before the eclipse. And what you should see is that you're able to correctly expose over a far wider range of different brightness levels. And that's what I'm planning to do at this eclipse. I'm planning to use the same gear again, but unlike the Australian eclipse, which was only 54 seconds, this one's going to be 4.5 minutes, so a lot longer to get some really good material. And I find video much more sort of immersive than stills, and these days the resolution of modern cameras in terms of video is pretty much as good as stills, and it's actually a much more forgiving way of shooting the eclipse. Another thing about exposures is that if we do have high cloud, if we do have cirrus cloud or even thicker cloud, all the exposure information that I could give you would go out of the window. You effectively have to adapt. And you can turn the exposure up to counteract the absorption due to the cloud. There's one other thing that having high cloud can do, which is actually make a very interesting phenomenon visible. So Nick mentioned shadow bands. So shadow bands are these things that you can see on the ground at second and third contact, like ripples across the bottom of a swimming pool, caused by the scintillation of light shining through a lunar valley. If you have high cloud, it acts as a screen, and you may be lucky enough to actually see shadow bands on that cloud. And these pictures, I think you can see here, these bands here are shadow bands projected on cloud, which was at an altitude of about 8,000 feet. Fairly thin cloud. So this is what you can see through fairly thin cloud. So even if we do have thin cloud during this eclipse, you can still get some really good images, and you may actually be able to see shadow bands. People saw this in binoculars. You can fairly safely watch up to third contact in binoculars, and people actually saw these shadow bands visually as well as photograph them. So that's a thing to bear in mind. Clouds, if we do have clouds, it's not the end of the world. There are other phenomena that we can see. The shadow rushing past us on those clouds, possibly shadow bands on the clouds, more enhanced colours around the horizon. So don't get really dispirited if we turn up at the site and there's a lot of high cloud. We'll still see a really impressive phenomenon. Just finally then, I mentioned that there's a comet. You may have read about this. There's a comet in the sky that's going to be fairly near the sun at totality. It's a comet called 12P Pons-Brooks. It's a comet. It's, in astronomical terms, it's quite a bright comet, but it's an extremely difficult comet to see even in the night sky, and it will be, I think, almost impossible to see in the bright sky of totality. But it should be something that's relatively straightforward to photograph if you have a wide-angle camera. And we've not seen comets, or we've not photographed comets very much at eclipses in the past. So this is an opportunity, if you're interested in taking wide-angle shots to include the planets, to actually get this comet as well. And this is an example of a 50mm lens field of view with the eclipse sun up the top, Jupiter down the bottom corner, and the comet's around here. So anyone who's interested in trying to do that, just set up a fixed camera with a wide-angle lens looking up at the sky, taking pictures during totality, underexposing a bit, and then once you've actually got the pictures at the end, you can have a go at stretching them, stacking them, and see if you can pick up this comet. It won't be spectacular, but it will be an achievement to do it. I think, to my knowledge, there are only 4 previous eclipses where people have actually managed to photograph a comet during totality. It's getting easier because digital cameras make it easier, and we were very lucky in Argentina in 2020 in the eclipse that very few people got to because it was right in the middle of the COVID epidemic, but AstroTrails got us there to actually photograph 2 comets during totality. So here's the sun, the eclipsed sun. Here's Mercury. There's a comet there where you can see a little faint tail. And there's also a comet very close to the sun, which was a real surprise, which was effectively being burnt up by the sun during totality. So those of you with the right equipment who are interested in having a go at doing it, happy to talk to about the techniques that you could use to try and get a very unique photograph. But I think for most people, the story is really don't try and be too ambitious. Yes, set up a GoPro, set up a phone to get some wide-angle video, try and get a memento for yourself. But there are people in this audience I know who will be on that site with lots of equipment and will be getting some really spectacular pictures, and I'm sure they'll be more than happy to share them with everyone at the end. So for most people, I think here, the real thing is watch it. It's an amazing visual experience. For those of you who haven't seen a total eclipse yet, you will be absolutely blown away by it. For those of you who have, well, you know why you're here. So that basically is everything. Nick's already shown these wonderful pictures of the corona. These were taken by Andreas Moller and processed by Miloslav Druckmuller. They show the corona more than you'll see with the naked eye, but they're much closer to what you will see with a naked eye view than most images are. You really can see phenomenal detail in that corona if you use binoculars during totality. So let's hope for clear skies on April the 8th. Let's hope everything comes together. If it does, we're going to have a really spectacular total eclipse, and that corona is going to be something you will remember for the rest of your lives. Thank you very much.